Well, here the question what we are having is about two stones. So, about two stones we are having the question, and both the stones are thrown up with different speeds, and the speeds are given here. One is with 30 and another is with a 50 meter per second upwards. Now you have to choose the best the drawing, the graph, which is suitable for the given situation. Remember, we are having more than one choice is correct. So for that, we have to know what actually we are finding. In first two graphs, we are finding the nature of the curve drawn, x2 minus x1, that is a relative position of the second stone with respect to first stone with respect to time. And in the next couple of graphs, v2 minus v1. So v2 minus v1 is nothing but the relative velocity of second stone with respect to the time. Well, so for this, I first say one thing. We have to think about the graph in two parts. That is, when both stones are thrown up, they go and come down, right? They go and come down. But what happens, by the time the two stones are thrown up, one stone reaches the ground quickly, whereas the other stone still may be in the air. So this may be the situation. For this, what we have to think is the graph, what we are studied for two situations. One is before the one stone reaches the ground and after that. So for that, what I have to tell you is, now I am doing the calculation like this. We have the formula x is equals VO into T plus half AT square. This is a well-known formula. So now for the first stone, which is thrown upward with 30 meter per second. So for that, the upward velocity is plus 30. So downward is the acceleration, that is 10. If g is taken 10, then what happens here? So this will be 5t square. So this is for x1. And meantime for x2, that is for second stone, this will be 50t. We already know the speed, 50. And again minus 5t square, this is what I can write. So now if you subtract these two, we'll get the relative position. But what I have to think is, the situation studied before the first stone reaches ground. Okay, so first stone reaches ground. So for this I say, let us think just for the sake of information that after what time one of the stone will reach ground first. You must know this will reach, the first stone will reach the ground first because it is having little velocity. So for that I think we use one more equation, that is V is equals VO plus AT, just to know. The downward velocity when it reaches the ground, again it will be with 30 meter per second, that is downward, that is minus 30. So that will be is equals, the upward velocity is obviously we know, which is plus 30, which is given, and this will be minus 10t, right, minus 10t. If you do this calculation, definitely we'll get t is equals 6 seconds. T is equals 6 seconds. That means this stone, the first stone, will reach ground in 6 seconds. Okay, so this will reach, the first stone will reach the ground in 6 seconds, but still the second stone lies in the air, and probably it may coming down. So for that, I suggest you to make the calculation like this. You know, before t is equals or less than, okay, so less than 6 seconds, t is equals or less than 6 seconds, you can use the equation for a relative position, that is x2 minus x1, that will be is equals, when you subtract these two, definitely the last two terms, that is 5t square may cancel, so leaving you with the value 20t, so it is positive. That means x2 minus x1 will be with the slope 20t. So 20 is the slope value, t is the variable. So definitely the positive slope we must get. That means we should get a straight line. A straight line. But unfortunately, we cannot conclude just by learning these things, because in both the graphs A and B, the beginning portion, say this one is at t is equal to 6 seconds. So we are having the straight line curve here. Meantime, here also in the second, within 6 seconds, we are having a straight line. So definitely we cannot conclude, because we doesn't know any values given on y-axis. So further, so after, right, so after t is greater than 6 seconds, so what happens? You know, the second stone still in air, but first stone reaches ground. First stone on ground, so on ground. So therefore, what you have to write for x2 minus x1? It is simply x2. Okay, so only x2. That means the x2 minus x1, x2 minus x1 will be is equals simply this one, right? So simply, so which is 50t, right? Which is 50t minus pi square. So definitely the shape of the curve is a parabola. Okay, the highest order is 2, so it's a parabola. So that means the correct graph is this one, not this one. So I hope you understood about this much. But we have to do one more thing, that is about the graph C and D. Know the nature of V2 minus V1 versus T. For this, I am making my calculation like this. So what I have to do is, to know the nature of that graph, the correct graph, I am doing my calculation like this. Okay, so say before, right? So before t is less than or equal to 6 seconds, V2 minus V1, V2 minus V1 will be is equals. So now it is a x2 minus x1, x2 minus x1 divided by t. So this will be is equals, now x2 minus x1 is nothing but this much within 6 seconds. So which is 20t divided by t. So to do further, V2 minus V1 will come. So it will be plus 20. So it is a constant. It is a constant. That means we should get a graph which is a parallel to time axis. So see, this 20 is having no term t. So that means it is a constant. So we should get a line parallel to time axis. Unfortunately, again, probably this could be the situation 6 seconds here. So within 6 seconds in both graphs, we are having the line of the curve which is parallel to x-axis. So one more time, we cannot judge the answer just by doing this much. So doing further, okay, so after t is equals 6 seconds, what I have to do is, V2 minus V1 is only V2 because it is only the thing, the second particle is only the thing which is moving now because first stone will be in rest. So with respect to that, it is approaching. So that means V2 should be negative. Right. So this means what I can write, it is x2 divided by t. So that will be is equals this much. What I can write, this much, which is 50t minus 5t square whole divided by t. Otherwise, I can write V2 minus V1 is equals V2 minus V1 is equals what I can write minus it is t, right? It is only t. Well, plus 50. So this could be the situation what we obtained. That means we will get the curve V2 minus V1 negative. Okay, so it should be negative. The value of V2 minus V1 is negative. Be careful. V2 minus V1 should be uh, should be negative because the velocity vector is pointing downward. So that means this cannot be the vector because here it is positive, but we may get negative here. So this option may go correct. So that means finally what I can conclude is from all these informations, the correct answers are one is option A and the second one is option D. So these two options are holding good in the given question, this one. Well, here in this question, we are having two particles, A and B, are moving in same direction as shown. They are asking the correct meaning of the velocity of approach among the given choice. So for that, we have to assume like this, velocity of approach. And let me assume B is still moving in the same direction, and this is B with the velocity VB. Okay, so it's a vector, no doubt. So meantime, if I represent the velocity of a vector VA, that means the particle A, like this, VA. So definitely this will be minus. Okay, so this is the correct way of representing any vector. So it's minus VB, minus VA. So now velocity of approach. Okay, so velocity of approach. Velocity of approach VB. Okay, so then what happens here? So the two particles now moving in same direction. That means we have to sum it. So plus of the second one, which is minus VA. So the meaning goes right like this, VA minus VB. So this is the correct representation. That means option D is correct. So here in this question, a particle is thrown up inside a stationary lift of sufficient height. The time of flight is t. Now it is thrown again with the same initial speed v0 with respect to lift. At the time of second throw, lift is moving up with speed v0 and uniform acceleration g upwards. The acceleration due to gravity, no, the acceleration of the lift upward is equal to acceleration due to gravity. In the second situation, we have to find the time of flight. Okay, so when the lift is at rest, okay, in this situation, what we can think is, when the stone moves up, with velocity plus VO, it again comes down to the same point with velocity VO but negative in direction, that is opposite. So that means using V is equals to VO plus AT, we can get the time of flight relation like this. This is minus VO and this is plus VO. This is the final velocity and this is the initial velocity. Both are in opposite directions. Minus this is a GT and the symbol for time should be capital T, which is said here. Okay, so when the lift is stationary, the time taken by the particle to come back is T. So solving this relation, I can easily write that GT is equals to VO. Let it be here. For some time, let it be here. So now let us think, when lift is accelerated or when lift starts moving, starts moving with the said acceleration, which is acceleration of the lift is equal to magnitude of g, but it is plus g, right? So acceleration of the lift is plus g. Now when you throw the particle upwards, particle whose acceleration due to gravity, the acceleration on it will be acceleration due to gravity, which is acting downward. Meantime, the lift is coming up, right? Lift is moving up with acceleration plus g. So that means both accelerations are opposite in direction. That means the relative acceleration, okay, so acceleration of the particle with respect to lift will be is equals minus g, which will be is equals minus 2g. Both are opposite. So acceleration of this particle will be minus 2g. So now with respect to lift, the displacement of the particle can be found x is equals VO into t plus half at square. This is the formula. So by using this formula, what we can use, what we can think, the net displacement of the particle should be 0 because it should go up and come down, right? So for complete displacement, the net displacement should be 0. So this is equals the initial velocity of the particle, right, with respect to you must be careful here. It is thrown again with the same velocity VO with respect to the lift. Okay, so now I am putting with respect to the lift. So with respect to the lift means I have to put here a plus VO, which is upward, right, into t. So this t is what I have to find now. In the second situation, this is the time I want. And now plus half into, so with respect to the lift, the acceleration of the particle will be minus 2g into t square. So now on solving this one, 2 get cancelled. That means minus gt square is plus this much is equal to 0. What we are seeing, this can be written as gt square, which is equals VO into t. Otherwise I can write it is t is equals VO divided by g. Now we have to guess what actually it is. It is a constant VO divided by g. From here, here what I can write is VO divided by g is t divided by 2, right? So VO divided by g is t divided by 2 from this relation. So now use this one here in that equation. That means t is equals, what I can write, instead of VO divided by g, I can write t divided by 2, capital T divided by 2. So that means the time of flight in the second situation when the lift is accelerated upward and moving with velocity VO, the time of flight of the particle inside will be capital letter T divided by 2. This should be the answer. So that means option B comes right.